All right, so now that you've actually legitimately spent some time with me with these sheets, I have a little, for focus boards. Is this a pile right here? Yes, we take my desk and all right. Oops, that's not great. Who found a problem now we need to do? Hey, 24. Eli caught 2 baseballs on the first day, 5 on the second day, 8 and 11. What kind of a sequence do we have right there? That's arithmetic. So you're going to have all the formulas. The arithmetic formulas are these. How do we know they're arithmetic? How do we know the formulas are arithmetic? No R's, right? No R's. R's are ratio, R's are geometric. So we're going to have that list of formulas. These are the only ones that don't have R's. So I'm going to be using one of these. All right, what does it say? How many will he have caught altogether if he does this for 100 days? Now, wait a second. How many will he have done altogether? Doesn't that imply I need to add them up? So I'm going to be using S sub 100. That's 100 over 2. The first term was 2. Oh no. What goes here? A sub 100? Do I know A sub 100? Nope, this happens to us all the time. I don't know what I need, so I'm going to use my other formula to find A sub 100. So that will be 2 plus, how many difference is 3 times 99? So then I'll figure out what that is. 2 plus 3 times 99. 299. Now, that isn't the answer. That is how many balls he caught on day 100. So that's what goes right here. And then I can figure that out. So I add 2 to it, multiply it by 50, and the answer to the question is 15,050 balls. Okay, Maeve?
Yeah.
All right, who else had one? Let's go this side of the room. Anybody over here have one from this side of the room? And then middle, you're coming up next. No? Middle will go with you while they're figuring it out. 13. 13. A, B, or C for you? A. So we are adding A, this is A, plus 2 times B. How do we get 2 times B? I'm adding A plus 2 B's. So 2 B's, I just multiply everything by 2. So it's going to be 0, 10, 8, 2. And then how do I add them? Entry by entry, right? So 1 plus 0, 2 plus 10, 3 plus 8, and negative 5 plus 2. There you go. Now, sometimes there are addition problems that aren't addable, because in order to add, this works, but in order to add, these guys have to have the same dimensions, right? So if one's a 2 by 2 and one's a 2 by 3, then I wouldn't be able to do the problem. All right, this side, did you find one? 4B. 4B is a logarithm equation. Remember, logarithms were at the very, you might not remember, but they were at the very end of the first semester, and so I didn't put them on the exam. So I told you then, these are going to be on your second semester exam, because they were the very end of the semester. So if you're looking for notes, this is actually chapter 3. We have a few chapter 3s in there. We need to combine this into one logarithm. You cannot have side of the equation. So we're gonna put them together. And when we put them together, since that's a minus, they're gonna go together as a division. So instead of having two logarithms minus each other, we have one logarithm of a division. Then we can ditch these and say x plus 3 over x equals 5. So x plus 3 equals 5x. 4x equals 3, and I got 3/4 as my answer. Do not drop the logarithms until you have just one on each side. All right, now we're back over that side. Do you guys have any more over there? 15. I have 3 yellow, 7 blue, 10 green. All right, I'm gonna write that down so I can keep track. So I have 3 yellow, 7 blue, 10 green. Maitland picks 2. What is the probability that she will get all blue? So in other words, this is like a card problem, only instead of picking 2 diamonds, I'm picking 2 blues. So what's my denominator? How many candies, how many candies do I have all together? 20. I have 20. So in a card deck, I have 52. Here I have 20 candies, and I am picking 2 of them. That's my denominator. This is exactly like a card problem. Now what do I want in the numerator? I want to pick 2 blues. Well, how many blues do I have? 7. And I'm picking 2 of them. That's it. Type it in on the calculator, get a decimal or a percent, however you want to answer it. This is going to give you a decimal. You can change that to a percent. All right, you see how similar that is to a card problem? It's exactly the same thing. All right, this side over here, you guys figure one out yet? 4D is an exponential. No calculator. That means I have to get a common base. Ideally, I will set my exponents equal to each other, but I can't because that's a 4 and that's an 8. So Gavin's back there going like this because my common base is going to be 2. So 4 is 2 squared. 8 is 2 cubed. Somebody asked me about this earlier. These get multiplied. So I have 2 to the 4x minus 6 equals 2 to the 9x plus 3. Now I can drop the bases and set these equal to each other. So it's similar to the logarithm thing. Once you get log equals log, you can just forget that and set these equal. Well, once you get 2 equals 2, you can forget that and just solve 4x minus 6 equals 9x plus 3. So, let's see, that's going to be 5x equals negative 9. I got negative 9/5 as my answer. Perfectly okay. Exponents and negative, it's okay. All right, good. Can you guys find another one? If not, we'll go somewhere else.
You do 26, please.
26? Right, 0.27 as a fraction in lowest terms. Okay, so this is a harder one because the 2 doesn't repeat. So we have to split that off and say, okay, this is 0.2 plus 0.07, 0.007, and so on, because these 7s just keep going. Now, this part is separate because it's different. This part is an infinite geometric series. So I am going to use my formula to add up that part. So the formula I'm going to use is this one. This is my infinite geometric series formula. And you saw the reference sheet. The formula is there, but I don't tell you what it's for. So you need to know that's your infinite formula. So the first term I'm adding is 0.07. What's my ratio? How many digits are repeating? How many digits repeat?
0.1.
1, so it's 0.1. So I have 0.07 over 0.9. I go ahead and always subtract my denominator. Then what do? Move the decimal 2 places, so I have 7 over 90. And then I have to add back in that number that I left off. So I'm gonna add back in 2/10, which is 18/90. So I end up with 25/90, which actually reduces to something. Where does that reduce to? 5/18. And then, oh, I don't have a calculator, so I can't check on that problem. But if I had a calculator, I would do 5 divided by 18, and hopefully it would come up looking like that. Okay, so here's what I need you to do. I need everybody, I think I might have everybody grab one of those. Spend some time tonight, do at least half of those, so tomorrow we have a place to start with our review. Alright, everybody gets one of those. You can tell them apart, because the one you just picked up says number 2 on it.